Okay, so I guess one of the main outcomes from that video was having a look at this concept called the 5-number summary. So I'm going to briefly make sure that you're across this detail, and we'll move on from there. So the 5-number summary is designed to give you an overview of a set of data and its dispersion, its spread, as opposed to mean, median, and to a lesser extent mode, which is designed to show you a snapshot of the data's central tendencies, what is happening in the middle of the data. Median's a bit like that as well. Okay, so we've got those 4 there, and what I've decided, 5 there, it's called the 5-number summary, and what I'm going to do is I'm going to use this example because it happened to be in my GDC already, really, from that video that I presented to you. And you can see here I've got a set of scores. There's no context to them. If you want, you can say number of hot dogs eaten over an hour by a particular number of people, if that helps you make sense of it. So 1 up to 6 frequencies there, and you'll notice I've got a cumulative frequency column as well. And later in this lesson, we will come back and have a look at a cumulative frequency graph or diagram. And I'm going to hammer home the cumulative frequency graph because I was looking at the past exam papers, and I know that Maths AA's only been going for a year and a bit, but looking back to Maths AA and then to Maths SL, they always seem to have cumulative frequency graphs as part of their questions. So I really want to hammer that home to make sure that we're okay with that. Plus, it's also useful with measures of spread anyway to have a cumulative frequency column, and you'll see that in a second. Okay, so here's the easy question. We look at our graph, our data, and we've tabulated it into a frequency distribution table to make it easier for us. And now we need to read the data off. So what is the minimum value from that example? Lily?
1.
Yeah, easy as that. You can see that it was going to be easy, so I haven't given you much space. I will. There we go. So it is just the smallest score available, so minimum score. What's the maximum? Zoe G?
6.
Yep. With the same level of complexity there that I gave for the minimum. Minimum 1, maximum 6. Now the median, I've given a fancy name for it there, the 50th percentile. So percentile is basically what percentage through the scores have you got through what percentage of the scores. So the first percentile would be what score is 1% of the way through the data. The 17th percentile would be what score is 17% of the way through the data. But we have special percentiles that describe data in a much more meaningful way, I suppose. I don't know why you want to know the 17th percentile, but knowing the 50th percentile makes sense. It's halfway through the data, right? So that basically means, to confirm what that means, it means that if I ordered the data from smallest to biggest, which score would be halfway through the data? So it's the 50th percentile, and this is where the cumulative frequency column really comes into its own, in that the bottom number here tells me the total frequency, which is 60, which means that halfway through the data is 30. Yeah? But that's not quite true. 30 is the top of the first half, and 31 would be the bottom of the second half. So we talked about this briefly last lesson, and that is if there's an odd number of data, then the middle is just the middle. But if there's an even number of data, then it has to be the average of the 2 middle scores. So that's what I'm going to write here. So the 50th percentile, so for this data, that would be the 30th plus the 60th, sorry about that, 31st, divided by 2. Does that make sense to people? So there are 29 pieces of data below the 30th and 29 pieces of data above the 31st. If we took it as the 30th only, then there'd be 29 pieces of data below it and 30 pieces of data above it. So it wouldn't actually be even. Is that making sense? Okay, now in this one, we can go to our cumulative frequency and we can say, well, up to 3 here, it's the 29th piece of data, and then score number 4 would be the 30th, and score number 4 would be the 31st. So that becomes, boringly, 4 plus 4 divided by 2, which is just 4. Does anyone have any questions about that particular calculation? I'm disappointed because there should be. Shall I ask it instead? Richard, yes. What do we really have to do a calculation if I can see that the 2 middle scores are the same score? No, of course not. If you can see the 30th and the 31st is actually the same score, then you can just chuck 4 out. So I've put the calculation there as a matter of completeness, because sometimes you might find if this was instead 30 here and this one here was 31, so cumulative frequency was 30 and then this was 37 like it says here, sorry, then I'd know the 30th score would be 3 and the 31st would have to be in here, so it would be the 4. So it would be 3 plus 4 is 7 divided by 2, 3.5. Does that make sense? So you don't have to really worry about it when it crosses that boundary. It doesn't in this data, so it's poor choice by me, but you get that. 25th percentile is what's happening a quarter of the way through the data. Now, I find it easy just to simply talk about it as being like this. Imagine in your head you've got 60 pieces of data and you split it into 2 piles. And you've got 30 in the first pile and 30 in the second pile. Split each pile into 2, and that would be your first quarter, and then split the second pile, that would be your third quartile. So the 25th percentile is got by halving the half, which makes sense because it's a quarter. So halving the half, that would be 15, would be half of 30. Because it's even, it's going to be the 15th plus the 16th divided by 2. Again, quite boring. Where's the 15th? Where's the 16th? Yep. So 1 only goes up to, only counts for the first 10 pieces of data. 2 takes on the next 7, from 10 to 17, so it takes on the next 7. So 15th and 16th is definitely in there. So that would be, for completeness sake, 2 plus 2 divided by 2, which is just 2. Can I give you a moment to think about where the third quartile would be? Not what, but where. Good morning, Tara. Okay, so I'm talking about this line here where I said 15th and 16th. What's the equivalent for the 75th percentile, Will?
In the middle of the top 50% of the data, so
yeah, of course, it's not the mean, it's the 75th percentile. But what I wanted is the 2 positions. That's what I asked people to think about. Elizabeth, did you come up with positions?
The 45th position, so
Plus?
plus 46.
Yeah. You sounded very confident there, well done. So yeah, so if 30 is the middle, then add 15 to that, you get 45th, but it is even, so we have to do the 45th plus the 46th again. If it were odd, then you would just work out the middle score, because there'd be the same number of scores above and below it, but because it's even, we need to have an average of the middle 2, 45th and 46th. So where is that to be found? Well, up to here we've only got 37 scores, but from here to here we go to 48 scores. So that means 45th and 46th must be here. And so we have, boringly again, 5 plus 5 doesn't cross any boundaries there, which is just 5. Okay? Any questions? Zoe?
I have a question, but it's not directly about this, it's about the textbook work that I forgot to ask earlier.
Okay, you can ask me a bit later.
Yeah.
Just trying to remember. Yeah, so I want to go a little bit more before I move on to some textbook work. Then I'll come and answer your question too. So the 2 other concepts really briefly I wanted to go through is range and IQR. So just a reminder, I hope, because I'm pretty sure it was gone through in the video, range is max minus min. So that would be 6 minus 1, which equals 5. The IQR is the interquartile range. And so it's saying what is happening in the middle 50% of the data. That's what it means. What's happening in the middle 50%? So we had Q3 as 5 and Q1 as 2. So we would say, well, I'll say that first. Q3 minus Q1, which equals 5 minus 2, which is equal to 3. Now this data isn't that interesting, right? But if you can imagine you had a range of 1,000 and an interquartile range of 100, then you could see that the total overall range is quite spread out, but the middle 50% is quite condensed in comparison. A range of 1,000, but an interquartile range of 100 would mean that 50% of the data is squished in. Okay? So that tells you something about your data, which is why we put these values together. Okay? So the 5-number summary allows us to work out the range. So the range is a summary of 2 of those values, and the interquartile range is a summary of 2 other values, and then the median gives us the middle itself. So it's a summary of a summary of these 2. Okay, exercise 6F, I'm going to be very strict on this. 15 minutes including marking time, and then we're going to go on to box plots. If you've got questions about the textbook work, this will be a good time to do it. Okay, so here's the example from my GDC. It has no more meaning other than that. And from the textbook, they gave you the data upside down as well, 6, 5, 4, 3, 2, 1. Usually goes from smallest to highest like this. But I just wanted to show you that, I showed you this in the video, but I just wanted to show you one thing I didn't show in the video, which is that I select the column by going up as far as I can and then it highlights, and then hold shift to get this. Then I press menu, go to statistics, go to stat calculations and go to one variable statistics. The reason why we highlight the columns is because these are then filled in automatically. If you don't fill them in order, if you don't highlight the columns, I think you have to select these manually. First result column is in the C column, which is what we want. And then I'm just going to press enter. I use tab, by the way, I find this faster. Use tab to go through the boxes to the OK, and then press enter to get there. And in the video, I was really focusing on the mean, 3.65 in this instance. And I said, there are other things underneath like sum of X and whatever else. But what I shouldn't have, but what I'd like to point out too is that some of these extra summary information, summary calculations are underneath. So you've got total of F there, 60. You've got min, first quarter, median, and third quartile, and maximum there. So the 5-number summary is located in your GDC column of calculations for one variable statistics. So literally in an exam, if you've got the data set in your calculator already, just run the stats rather than calculating them by hand, and then you can work out the interquartile range from there. One other thing I wanted to point out was that if you go to menu, hang on, I'm not too sure whether it needs it or not, but I'll just do it anyway. If I select my 2 columns again, I go to the menu button, and this time I'll go to data instead of statistics. You can do a summary plot. That's number 8. And then it will give me, say, where's your X list coming from? X. Where's your summary list coming from? F. How do you want to display it? I hate split page. I might always select new page for it, and then tab to OK and press enter. And there's your frequency histogram. Nicely done for you there, as you can see, with the endpoints as it should be, which you could then copy down if you needed to, or you can interrogate it as you need to as well. Okay, so very briefly, back to the notes. One thing the video doesn't go through, but the handout notes does go through, and I'm just going to do it in slide 80 because I've got this bit out of order here, is outliers. And the textbook does a good job of explaining what an outlier is, which is basic. I mean, basically, at the end of the day, an outlier is a piece of data that may not really fit the set. And it could be because of a calculation error or a data entry error, or maybe it's just someone that's or something that's extraordinary, and by that I mean extra, out of ordinary. Okay, so what the textbook says really clearly, and I agree with it, is that outliers should be treated case by case. Sometimes there's a good case for outliers, and sometimes there isn't. In terms of determining if a value is an outlier, the standard approach is an outlier would be either take the value of the third quartile and add 1.5 times the interquartile range, or take the first quartile and subtract 1.5 times the interquartile range. If a data point, if a score fits below or above that, then it's a case for being an outlier. There are different techniques that are used for working out if something is an outlier or not, but this is the one that the IB uses, and it is a very common one. Okay? So if you're asked, is 28 an outlier? It expects you to do this calculation to determine if it is or not. We clear on that? I'll do the calculation for you in a second. But as the IB says, as the textbook says, you should always then go, should I treat this as an outlier? So I guess the idea is that the calculation gives you a sense of the boundaries, and then your mathematical sense takes over to say, but is it an outlier or not? And we'll have a look at the textbook in a second to get that. But for the data I just gave you, so I'll just zoom out so you've got it all. For the data I gave you, the Q3 is 5. Okay, so we have Q3 plus 1.5 times the IQR would be 5 plus 1.5 multiplied by 3. And that would be, what, 3, 4.5, 9.5? Or Q1 minus 1.5 times IQR, which would be 2 minus 1.5 times 3, which is 4.5, which would be negative 2.5. Okay, so we would say anything above 9.5 or anything below minus 2.5 would be considered an outlier for the data set I just showed you. Again, because I'm just making this up on the spot, the numbers aren't very nice, but based upon that, there is nothing in that data set that would be considered an outlier. Okay?
That includes 1.5.
Yes. Good question, Sam. I believe it is. Looking at the textbook very briefly. There we go. Extreme values are called outliers that might be considered from removal. Yeah, it says any value at least that. So that would be inclusive. There's an example from the textbook. You can look at example 10 yourself. But this bit here is the thing I like. Let's see if I can zoom up a bit. You've seen how to identify an outlier, and now you must decide whether to reject or accept it. Outliers can have a distorting effect on statistical measures like mean, but some are still valid data values. And then they have an example which I thought was worth it. Yeah, these two cases here. So
382.
in the case of the heights of 15 boys in centimetres, there they are there. And you can see out of that set of data, 382 would mean that that person was almost 4 metres tall. And we can pretty safely say that's an outlier.
And 182, but not 382.
Yeah. Um, in the case to keep an outlier, what their argument here is 89% is not an error, but it is unusual. So it's definitely an outlier. But then the teacher has to conclude one of two things. Does the teacher keep the 89% and say maybe that student is a good representation of the test and that the other students haven't studied that hard? Or was the teacher too difficult and therefore the 89% shouldn't be included? So it comes down to, definitely a sense of integrity, I suppose, to determine whether an outlier supports your data or not. You shouldn't just take out outliers because it confirms your narrative. You should take out an outlier because you think it's distorting the data unfairly. Okay, so you don't automatically discard outliers. Is the point there?
That you're not going to discard anything that's not within the...
You should not discard things that aren't outliers. Yep. I can't think of a justification for that, really. Box plots. So I describe box plots simply as the 5-number summary as a picture. So I've got the data over 2 pages, so sorry if I'm going to continue to flick backwards and forwards here. But we've got the minimum and the maximum. Oh, thanks. The minimum and the maximum is 1 and 6. And so what I do is with my box plot is I put a little whisker here. I'm doing this freehand. It's better to do it with a pen, with a ruler. And a little marker here, so for the minimum maximum. Then I have a look at the interquartile range itself, and that is 2 and 5. So I have the start of my box here and the end of my box here. And then I draw as neatly as I can so that it all joins up. And then I extend my whisker, I extend my line that way and my line that way. And then lastly, I put in my median, which was 4, wasn't it? Yeah. Which is there. And that's my box plot done. So the box represents 50% of the data. Okay? So the squishier the box is, the more compressed my 50% of my data is. My middle 50%. My median, as you can see, is ranging or heading towards the top end. Okay, so that means that my data, the middle 25%, I'll my point for us, so I can show you what I'm talking about. This is a little bit more spread out than the next 25% of data. So this is my 50% of my data. This is my first 25%. This is my second 25%. I'm not saying that very well. This is my first 25%, isn't it? This takes me up to the middle of the data, so from 25 to 50%. This takes me from 50 to 75. Okay? So between the 25th and the 50th percentile, the data is a little bit more spread out than it is between 50 and 75. So that's the interpretation there. And then my whiskers extend out so you can sort of see the full extent of my data. Now, I haven't got this. I'm going to do a real scribbly one here to show what it looks like, so I don't have an example in mind. If your box and whisker plot looks like this, but you have outliers, the outliers, however many there are, can be written as dot points like this. Okay, so if you see a box plot like that, these are outliers, and then this is the rest of the data. Yeah.
In our exams and stuff, when we have like interpretation questions related to this, and we have outliers, do we have to discuss why the outliers exist?
As in, normally the exam will ask you to identify if something is an outlier, rather than explain why it's an outlier kind of thing. So using the calculation more than anything else. Yep. But of course, we're not here just for exams. Okay, so that's box plots. It is now 9:10. I'm going to give you 10 minutes to work on exercise 6G, and then we're going to move on again. Most of them are about interpreting box plots rather than drawing them. And sometimes you'll find 2 box plots on top of each other. If I can find some examples of that, I'll do that maybe next lesson. I'll stop the video now, and then we'll come back for cumulative frequency graphs. So a couple of things I wanted to point out. Number one, thanks to Zoe, who worked out that if you're given a set of raw data as opposed to a frequency distribution table, you can put the raw data down in column A, just in any old order at all. It'll still do the 5-number summary for you just by selecting column A instead of column A and B. Just select column A, and it will work out all those lovely values for you. And there is a sort function as well, so that if you need the data sorted, then you can do that as well. So thank you, Zoe A, for figuring that out for us. I do seem to recall maybe occasionally a question where you're given raw data as opposed to a frequency distribution table. So it's absolutely worth knowing that you can just chuck the raw data in there and still get the same data out. If there's no need to sort it, don't sort it, because the GDC will do that for you anyway. The other thing I wanted to point out is I'll go back to my tab here, which is my histogram, my frequency histogram. And if I hit the menu button on this particular page, you can actually choose the plot type. And by default, it comes up as a histogram. But as you can see here, it also allows you to view it as a box plot instead. So if I press return now, there is a box plot.
Doesn't have any. Graph it again.
So you've got from 1 to 6 with the median is 4. And as I'm hovering, you can see that it's also giving me the values: Q1, Q3, median, minimum, and maximum. So all of that data is there for you on your calculator. Zoe just asked how you do that again. So just a reminder that you select your data. In this case, I want data and frequency. Hit the menu button, hit the data, which is 3, and then hit summary plot. And when you do that, I won't do this final line because I've already got it open. I would go to display on and click on new page, and then click on OK. And then you can click to your second page and then change it from a histogram to a box plot if you want to. I don't think you do. I think if you just select one single column, I think it'll just give you a box plot, but I haven't done this in a while, so I can't remember. It doesn't like it. The other thing that I know you can do on your GDC, but I can't remember how, but I'll look it up, is you can do 2 box plots. And 2 box plots are really useful for being able to compare 2 sets of data. So like if you've got, let's just say, like Kate and I, for example, Kate Sinclair and I teach a maths methods class each. And if we were, for example, trying to analyse how we're going in class, if my box plot is like this, and her box plot is like that, having them side by side like that allows us to really analyse what's going on in our classes. Like my data's a lot more spread out, my median's higher, blah, 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 blah. She's able to get more consistent results in the 50%, and they are higher than my middle 50%, that kind of thing. So so it's quite really useful to compare 2 box plots at once. Excuse me, we've got about 10 minutes left, so I want to leave you with cumulative frequency graphs, and then you can do some for homework. 9 times out of 10, cumulative frequency graphs are all about the given one, and you have to interpret it. But I don't think cumulative frequency graphs are things that you've had to do before. Am I wrong? Right? Am I wrong? Not sure?
I mean, if you draw one, we might remember.
Okay.
It just goes.
So here we go. So I've just copied the table from the first page there. So X, F, and CF, and the cumulative frequency graph. You might have done a cumulative frequency polygon actually. But anyway, this is going to be pretty rough since my sketch is just that, a sketch. But basically, I'm plotting my scores.
It's the J. The S, the
Yeah, it's often an S. Probably my scores against my cumulative frequency here. Now mine's going to be pretty rough, but you'll get the idea. So the first one is 10. So I might just change colour. I'll change it to red for the dots themselves. So there's 10 there. So score 1 is 10. Score 2 is 17, which is going to be roughly there. Score 3 is 29. So it's roughly there. Doesn't have to be an S. Score 4 is 37, so that's going to be roughly there. Score 5 is 48, so that's going to be about there. And score 6 is 60. So there's my frequency, cumulative frequency graph. They tend to be like this, or sometimes like this, but in this instance, I'll just join the dots. Should be a smooth line, like so. It's almost always done on graph paper. And something which I don't see done in exams, but I certainly would teach it this way if I were teaching a class regularly outside of the IB, is that this is an example of a graph that quite frequently has two y-axes. On the left-hand side, we have the frequency, and on the right-hand side, we have the percentage, or the cumulative frequency. We have the percentage cumulative frequency. So 50% would be 30, and then 25%. So you're literally just measuring off like so. And that means that if you're asked what the 75th percentile is, you basically go along to the graph and then down there, and then say, this is assuming it's continuous data, we estimate that the 75th percentile is 4.8 or whatever, 4.9. So you're reading off the graph and then going down to the score. Otherwise, you're saying the 75th percentile is here. You go across here and then down here, that kind of thing.
So that's what you're more likely to be asked in terms of exams, is stuff like interpreting and finding values from.
So you'll see it on Friday, but typically what happens is you're told, here is a cumulative frequency graph. Estimate the third quartile. Estimate the first quartile. What is the interquartile range? And so you're going along here and saying, well, it's 60, so that makes it the 15th and 6th, what was it, the 45th and 46th. So that's about there. Go along, read that off, there's your answer kind of thing. That's basically what you're doing. I haven't really seen the percentage off to the right. You could certainly do that yourself if you thought that was helpful. Okay, so the textbook gives you interpretation questions where you've got a cumulative frequency graph and you need to just sort of work out values. In the sheet set that I just handed out, you've got a combination of stuff where you're given intervals, class intervals, data. You have to work out the cumulative frequency yourself. You then have to draw the cumulative frequency graph. I think it's worthwhile doing, because I think actually building it for yourself helps construct better meaning than just reading a graph. So I would like everyone to have a go at doing this booklet between now and Thursday. The textbook work is exercise 6H. It's in your work schedule. So you can have a go at that if you want more closely aligned to the IB kinds of things. But I found that booklet I handed out pretty good. And just to summarise just so I don't have to disturb you between now and the end of lesson, what I handed out was Unit 5 box plots. And that has some more theory in it, if you need it, plus some specific examples, which returns you to the world of hot dogs, so that you've got some exercises that are focused on that video. So I've given you more stuff that I know that you can possibly do, but it's so that you can pick and choose, and you've got plenty of work from which to look at if you need it. Okay, so I'll stop the video now. We've got about 3 minutes before it's changed over to lessons, so work through that cumulative frequency booklet for the next 3 or 4 minutes.